Yeah, hello everybody, welcome back to Shutters and Speed. Yeah, you joined me today on the A17. I'm just heading up into Lincolnshire for a bit of a spin, but one of the things I'm looking to do today is another episode of the local landmarks series that I've just started. We've had a look at one local landmark already, which is Bawsey Ruin. A link to that will appear up here in the corner and also in the description below. But today we're going to go and have a look at Sutton Bridge. So without further ado, we will, as we say here in Norfolk, we'll run them their titles, boy, and get into it. Yeah, so welcome back to Shutters and Speed. Yeah, today we're heading, as I said earlier, to Sutton Bridge. I've made arrangements with a chap I know who actually runs the show, as it were, and he's arranged for me to meet somebody who's very big on the history of the bridge and also the workings of it, as it were. And he sort of said to me that he would perhaps be able to take me around on a tour and we can have a look at it in quite a bit of detail, which I'm very much looking forward to. Now, Sutton Bridge, of course, is the main gateway from people in Norfolk up into the Lincolnshire Wolds and Lincolnshire and, of course, the north of England. If you're coming down from anywhere sort of, I would say, north of Birmingham, the chances are you will cross the bridge if you're coming into Norfolk. So it's quite a landmark, and it's also very popular amongst the local people as well, who sort of, you know, I think they look on it with some affection, which is obviously great. So I'm looking forward to going and having a close look round. I've been over it many times myself, and you know, in either in the car or on the bike. My son lives in Lincolnshire, so that reason alone is enough for us to bring us from here in Norfolk up to Lincolnshire and across the bridge, of course. So I'm very much looking forward to having a look at it. I've seen it open a couple of times in my time crossing it, but I've very rarely seen anything other than it just open and nothing happening, because obviously I'm in a queue of traffic. So I'm very much looking forward to filming not the thing sort of statically, as it were, and also with it opening and closing and a boat going through. So hopefully this will all come together, and we will hopefully enjoy the look round as well. So it's all good stuff, I think. So hopefully you'll enjoy what comes along soon. But as it is at the moment, I'm just making my way along the A17. Now, this is not one of the most scenic roads or the most enjoyable roads in the world, and of course when you're making your way up to Lincolnshire, or anywhere for that matter, if you want to head up north to the Lake District or Scotland or North Yorkshire, you probably have to come this way, and you have to endure this road for almost its entire length, which can be sort of 50 or 60 miles if you're going up to Newark and getting onto the A1 that way. But of course, if you're heading into the Lincolnshire Wolds, it's not quite as far as that. You're probably looking at about an hour and a half from where I live in Downham Market to the fun stuff, but then you've got all day to enjoy the roads and all that they have to offer. And of course, there's always a nice stop to be had at Winningham Woods should you wish to. But before we do all that, we've actually got to cross over go through the gateway into Lincolnshire, and also the reverse back into Norfolk, if you like, and cross what is Sutton Bridge.
So as the bridge comes into view, just grab yourself a cup of tea and sit back and enjoy this fabulous insight into the operation of this bridge. Yeah, so we're up here now in the operational centre, as it were, the turret on top of the bridge, with our good friend Robin here, and he's going to actually try and explain to us how it all works from up here. So over to you, Robin.
Oh, good morning. Right, so before we start swinging the bridge, obviously the first thing we've got to do is stop the traffic. So that usually causes a few problems, because there's usually some reluctant people who don't really want to stop because they're on their way to work at 8 o'clock in the morning, which is understandable. So we have had a few incidents with people knocking into barriers and that, but hopefully that doesn't happen too often, because that's quite expensive. So once we've got the traffic stopped, then what we have to do, we have to actually raise either end of the bridge hydraulically. because the bridge sits on things called slip blocks at either end and a central bearing obviously in the middle. So the first thing we've got to do is raise either end of the bridge with hydraulic jacks, and then we can remove the slip blocks. Once the slip blocks are removed, the jacks return, and then either end of the bridge is just like literally hanging in space. So the bridge is then resting on the centre bearing. That means the bridge is then ready to slew. At that point, we can then operate the hydraulic slew motor, and the bridge will turn very slowly. Obviously it starts off in a creep mode because we don't want it racing away if there's any problems to start with. Once that gets beyond a certain degrees, then the swash rate of the hydraulic motors goes up and we're away, and we're usually travelling at about, we're usually running at about probably 10 feet per 10 seconds, something like that. We then at that point tell the ship that we're opening, because he needs to know, so he can keep coming down the channel. When we got an inbound ship, you've got to remember he's coming in on a flooding tide. He's coming in at probably 6 knots, water's moving at 6 knots. He can't stop if things go wrong. So this is questions often asked me, why we open so early. We have to, because that gives the ship time, if the bridge fails or breaks down, to actually pull in somewhere, hopefully at Sutton Bridge port. But if he's got beyond that, then his remit is basically to run into the bank rather than hit the bridge, because if we were to hit the bridge, everybody would be going via Whiz Beach for the next 10 years while they build a new one. So that's why we open about 15 minutes before the ship comes through, and that's really a safety thing, because we do get breakdowns on a regular basis. Just the other morning, none of the barriers would come down, so me and my friend up here were running around like blue arse flies, and you know, just basically trying to pump things down, telling the pilot on the ship, please slow down. So it all gets a bit stressful at times. We're having some modifications done at the moment. We're going to be electrifying the bridge from the slewing point of view. It'll still be lifted hydraulically, but the actual turning part will be controlled by an electric motor, which hopefully will be a lot more reliable. We're still operating on kit that was built in 1897 when this bridge was built. There were 2 bridges here previous to that, earlier in the 1800s. That is really the reason this bridge is now right on the corner, which makes it difficult for shipping. When you watch shipping come through from up here, it's on a turn, on a corner, so the pilots have to be very, very skilled to get it through. We've only got 21 metres gap here. Some of those ships are 16, 17 metres. They haven't got a lot of room. So you see them when they're coming down the river. You can see them coming at an angle, and to most people go, oh, that doesn't look right. Well, it is, because he's actually turning. The reason this bridge is on the corner is obviously the earlier bridge had to be kept operational when the new bridge was built. So of course they've crept down. The first bridge was there, second bridge was there, and when this third bridge was built, that moved even closer to the corner. That's why we are where we are. So that's how it is.
Wow, yeah, that is some info. Let me tell you, that's great, Robin. Thank you very much. Now I do know that you sometimes, well, Pete was telling me earlier that sometimes the ships come through here, and because the tolerances, let's say, are quite tight, that sometimes they do rub against the bridge and make it wobble a bit. Yeah, we have had a couple of incidents. We've got fendering, obviously. The fendering wasn't put in that long ago. There's always been timber fendering.
Right. But about 20 years ago, they put they're big rubber fenders now. But it still makes a hell of a noise when they come through. Sometimes you've got trainee pilots, often on the ship, so he's having a go or whatever. Obviously the main pilot will be able to take over if it all goes wrong. But it's just glancing stuff, a bit of paint here and there, nothing too drastic. That's what the fenders are for at the end of the day. Obviously we have to put reports in and all the rest of it and check for damage, but luckily there's been nothing serious in my time here.
Oh, brilliant, that's great. So, Robin, let's just have a look at the controls, shall we?
Right, so this is part of the original equipment that was put in 1897, as you can see on the date here, by Armstrong, Whitworth and Co. Now this was built, the whole bridge was built for the Midland and Great Northern Railway. No longer a railway on the bridge, but there was until 1959. So the railway company built the bridge. Originally it was controlled with water hydraulics, so the water contains a little bit of glycerol to help it flow. And this would have been the original method of operating the bridge. You can't see from this point, but there's a hydraulic tower down by the other roundabout. Most people would have noticed it. That was the 2 hydraulic accumulators. They're actually still in there. So from a heritage point of view, everything's still installed over there. But they provided the pressure for the bridge. And this was just a way of opening and closing and allowing the fluid through. You would still have to use these levers to actually operate the bridge, but this basically gave you your pressure, let the fluid through, and you'd have a reading on that gauge down there. Once you've got sufficient pressure, again, the traffic would have been stopped by whatever method they used then. So you then got your 3 levers here for lifting and slewing the bridge. So the first thing you've got to do is lift the bridge. So I can show you on the representative on the computer in a moment. Basically, this lever here would be pulled into this direction. Now this still works, I hasten to add. It's wired into the computer system, basically.
Okay.
We don't need to use this. It's here from a heritage point of view. But what you would do, you would lift the bridge by pulling it all the way this way. What that would do is lower those 2 jacks either end, lift either end of the bridge. Once that was done, that would be returned to the mid position. And then you've got the slip blocks that the bridge sits on. To remove them, this would then be pulled this way. Those slip blocks would remove from underneath the bridge. Again, back to neutral. Then coming back to this control, which says lower, you would then lower the bridge, which sends the jacks back to let the bridge come down again. At this point, the blocks are out, the jacks are back home, so the bridge again is now sitting just freely on either end. This central control is the basically open and closing the bridge. So at that point, you would then pull the lever this way and the bridge would start to open. Bearing in mind, this is all done under a water hydraulic system. So if you needed a bit more power, you'd open that up a bit more, let a bit more fluid through. So it was all controlled. The speed then could be controlled via here. So when the operator was opening and closing the bridge, at the last part, when he was nearly open or nearly closed, he could use this to actually regulate the speed. Quite a skilled job. It's all done automatically now, so we don't have to worry about that. But these will work. They are wired into the system, and we can open and close the bridge with these, which we often do to demonstrate to people. This over here, this is the keep bolt. So when the bridge closes, from up this point, you really can't see it anywhere else. There's literally a hole in either end of the bridge, and this is no more than like a door keep. So when the bridge closes, the piece sticking out locates into that hole and stops the bridge going any further. That's because it was rails and they needed to be exactly right. So that then is returned into that position, ready for the next opening. So that what that's done is withdrawn the keep bolts at either end. If that's out like that and we tried to open the bridge, it wouldn't open because the keep bolts would be blocking the rotational movement. So that lives in that position, ready for the next swing. We still use it because it's good to have the curves lined up straight anyway.
Yeah, so what Robin is saying is he's remarkably described all these levers and pedals and whatnot to us, but they're not actually used on a day-to-day basis anymore. What we actually use is a computerized system. So we've gone from this malarkey, as it were, and we're now moving up to the sort of current day system where we've got this computerized setup, which is what Robin is now going to talk to us about and show us how that all works.
So if you look at this representation, it's basically a copy of what we've got on the levers on the floor. One to move the bridge, one to raise the bridge, one to take the slip blocks out. So we operate using that, and I can actually show you the position of the blocks. So that shows all the slip blocks are in and under the bridge, and the bridge is resting on it. That's the position of the jacks. So during an operation, all these jacks will start to move, and we know when a sufficient lift is because we get green light on all the micro switches. We then know it's then safe to remove the blocks. This computer system won't allow you to operate things in the wrong order. So basically, if you're trying to pull the wrong lever, it'll say to you, you need to do this or you need to do this first. So that's fine. The trouble is, and it's a great system, it's about to be upgraded, but it'll have the same graphics, so we don't need to retrain the operators. The problem being, when you move across to this box here. Now, when this goes wrong, we have to come to what we call the manual box. So we come up here to start with, we switch that system off, and we literally switch onto manual. At this point, you can do it all in the wrong order, and you can do an awful lot of damage.
Oh, right.
So when this happens, the only reason you go onto this is usually a ship's bearing down on you, bear in mind, coming in at 6 knots.
Yeah.
Something fails on there, you really have to think what you're doing. it's quite high stress.
Absolutely.
Because you can get it all wrong. Yeah. So you need to really go through this. So you need to have that sort of logical ordered mind.
Right, okay.
Where you can go through a processing, and that's what you need to stop and think.
Yeah.
Right, the
Yeah.
process is
Yeah.
start the pumps.
Yeah.
Talk to the captain.
Yeah.
Tell him we're
Yeah.
having problems and he'll
Yeah.
slow down.
Yeah, yeah.
And then we go on to the system. It
Yeah.
doesn't happen very often, but it has happened.
Yeah.
And it can be quite stressful.
Yeah.
With the new system that we're having installed, hopefully this will be removed and won't be necessary anymore.
Right, okay.
But so we do all the operation from standing at this point in front of the computer. You know, I can move these levers across. It'll tell me, look, pumps must be running and
Yeah.
all the rest.
Yeah.
So you can't do anything wrong on this.
Okay.
Um,
But you most certainly can over
with
here.
this, yes,
Okay.
yeah. Not our favourite device.
No,
but
no. But as you rightly say, if this goes tits up, which computers tend to do from time to time,
Well-
and you have to move over to this system, and you've got a boat coming down there at 6 knots, and it's nearly on you, and you're going to start a lot of normal people would just start pushing buttons here, there, and everywhere.
Yeah.
And so you've got to maintain your cool and go through the sequence as per.
I mean, it looks fairly straightforward, but I say,
Well,
if you do something before you do something else, it can all go horribly wrong.
right,
So,
okay. Yeah,
so
yeah.
I mean, obviously, yes, this is actually running, I believe it on a Windows 98 system.
Really?
Yes,
Yeah.
but it's going to be upgraded when they electrify the bridge to whatever the latest one is.
yeah.
Maintaining the graphics
Yeah,
are probably
yeah.
a little bit smarter, I expect.
Oh,
but,
right, okay.
Yeah, so that's it.
But
So,
I suppose at the end of the day, people bang on about operating systems and whatnot, but as long as the system works,
it does work, yes, absolutely.
Yeah.
There's rarely a system with the software itself.
No.
We get power outages and all the rest
Right,
of it.
okay,
So
yeah.
if we do get a power outage, if you look down there, we've got a lovely generator that's recently been installed, and in the event of a power outage while we're halfway through a swing, that will come on almost instantly. So you get a very slight interruption, half a second maybe. That red light on top of the cabinet in front will start flashing, so we know what's happened.
Yeah.
Then we just have to reset the computer, which doesn't take long, and then carry on.
Wow.
Usually, we don't have to even inform the pilot, it's that quick.
Right, okay.
That will then run for as long as we need it,
Yeah.
to open, close, or whatever.
So what sort of delay are you looking at then? If that
Well, if the mains power goes off, that will start within half a second.
right,
But obviously, there will still be an outage on the computer. Will detect that and will stop the movement it's doing.
right.
But then it's easy. We go back to a neutral position and then simply restart the pumps.
Oh, okay.
And then we start
Okay.
again. Yeah. So it's
Yeah.
it's not a problem.
Yeah. Oh,
We
right.
know that we can rely on that system.
Brilliant, fantastic.
So it's quite quick.
Yeah,
Yeah.
brilliant. Yeah, so as you've just seen, we're up right on the top of the turret here, and I've just had a quick look at the traffic coming across. And Robin was just saying about the possible inconvenience, let's say, to motorists if this thing doesn't work properly. So, Robin, how far round is it? Should you not be able to get across here?
Well, if you're local living, you live just one side of the bridge or the other,
Yeah.
you just want to get to the opposite side.
Okay.
The total diversion via Wisbeach is 23 miles.
Wow.
So, I mean, if you're just travelling north or whatever,
Yeah.
that's not such a big diversion because you're not trying to come back to this point
No.
and you'd be diverted from down the bottom of the A17. But
Yeah.
yeah, so 23 miles from one bank to the other bank,
Wow.
basically. Yeah. So yeah, we do get some some abuse at times if the bridge is closed. But you know, it's published beforehand.
Oh, right, okay. Yeah. But sometimes, like you sort of described earlier, there's a lot goes on, and if anything goes wrong,
Yes.
then that could happen at a moment's notice almost.
Well, another thing that, of course, can be a bit irritating is we'll be up here, you're on your own, you're trying to sort it out, and you have people sitting in the queue ringing the bridge.
Really?
Is there a problem with the bridge?
Yeah.
Yes, but I'm trying to sort it out, and if I'm not on the phone, so I take the phone off the hook
I'm
usually.
sure. I'm sure.
But it's 1897 technology. Yes, we've got a computer running a lot of the system, but all the hardware is pretty much the original hardware. I should think you'd find something built in the 50s wouldn't last as long as this.
Absolutely.
I doubt very much.
No, I doubt not.
So really,
No.
we've got to look after her. She's heritage.
Yeah.
Another thing people do suggest is a flyover or another bridge. That won't get rid of this bridge.
No.
Because it's heritage and it has to be preserved. There's
Yeah.
only one other like it in the country,
Yeah.
and that's the bridge in Newcastle.
Yeah.
That's a single track road only.
Okay.
But a flyover, we need to be, the ships that come through here are already way above our heads.
Yeah.
with a 30% clearance on a ship, which you need for flyover, your flyover would start about 1.5 miles that way and finish about 1.5 miles that way.
Wow. So that would cause some
it would, but also the land that needs to be purchased, the cost of building such a bridge.
Wow.
It's not going to happen.
I think we'll stick with what we've got.
Yeah. And even a tunnel is not viable because of the type of soil here.
So while we're up here, Robin, just give us a brief idea of the history. I mean, when it was first built, and I believe it was once a railway bridge.
Yeah. So this carriageway here, the westbound carriageway, was the railway.
Right.
Now the railway company, in their kindness, decided to put a road bridge on the other side. They didn't have to do that.
Okay.
It was built as a railway bridge. Much as the bridge down at Lynn was the railway bridge, that was railway only. There was another bridge that they had to build for the road.
Yeah.
So this was built in 1897. So Armstrong built the bridge for the Midland and Great Northern Railway. It remained a railway bridge until February 1959, when this line was closed. Most of the Midland and Great Northern branch across Norfolk was closed. A great loss, really. And for a while, they just put planks down on this carriageway and allowed it to be used by other road traffic. Because it was a bit of a bottleneck. You can see old photographs during the summer holidays, the summer periods in the 50s. You'd have a policeman, because that single carriageway is not very wide, and whilst you'd probably get 2 Austin A30s over it at the same time, if you had a holiday coach, that would have to be stopped at that end while, of course, and then we didn't have the crash barriers that we've got on there now.
No.
So it always was a bit of a bottleneck anyway. And the railway was mostly holiday traffic in the later years coming from Leicester, because everybody wanted to go to Yarmouth, and that was a very popular. But road transport just basically made it unviable, plus the cost of repairing the bridge at King's Lynn was the reason was cited for closing the line.
Right, okay.
There was a massive station here, right on the corner.
Right.
It really was a railway world.
Yeah.
The only thing you can see now that's left of the railway structure, apart from the bridge itself, we have one pillar down there that's an original Midland and Great Northern concrete pillar.
Really?
But everything else has gone, swept away.
Okay.
Our office now is where the old goods yard was.
Yeah.
The station's obviously long gone.
Absolutely.
And, it's a shame, but that's how it is.
Okay. So the other story we've got to tell while we're up here is, and I can remember this, there was a ship that got sort of trapped across the river. Just Robin, give us a bit of background to that then, Robin.
Yeah, so that was in 2000. That was a cargo ship called the Lagic, and we got a turning basin down at Port Sutton Bridge, which they don't use now because it's silted up. The captain decided to make a turn without the pilot, and he got stuck in the turning basin with a rapidly decreasing tide. And as you can imagine, 120-foot long steel boat isn't designed to be supported at either end out of the water.
No.
So many local people remember it.
Yes.
So that snapped in half basically, and was sat across the river there for 2 weeks while they chopped it up, took it out bit by bit. I understand the captain got the sack.
Really?
Unsurprisingly, but yeah, so that did cause some consternation. I mean, I wasn't working here then, I was still in the Air Force.
Right.
But I do remember coming across the bridge,
yes,
because people would just come up just for a look, really. So.
Well, I was no different. I mean, I can remember when that was actually being taken apart, there were crowds of people up on the river, on either riverbank, just standing there in awe almost of what had gone on. And, that's not something you obviously see every day, is it?
Fortunately, the cargo had been unloaded,
right,
so it was just an empty vessel at that point, so there wasn't any pollution or anything, but some very red faces, I think. That's probably about.
Right, so we've come down into the real bowels of the operation here, and we've got Robin with us again, and he's now going to explain to us what we have here in front of us.
Right, so this is the very centre of the bridge. So we've got all 700 and odd, nearly 800 tonnes resting on these 36 slightly tapered rollers. Obviously, the bed they're sitting on was also slightly tapered in, keeps everything in the same position. If it was just flat, it could wander off wherever it felt like. These are all the original rollers. Nothing's ever been changed here. It's the original roller bed. We've occasionally had to take a shaft out to replace some bearings inside, but pretty much this is as it was in 1897. So you can see this large rack we've got here, and most people when they first come and look at this they assume this moves. It doesn't. This bit and everything below these is static. What moves is this section here. Now this is the shaft that came down from the top where we had the quill shaft tops and the gears at the top. Inside here, that shaft which is exposed further up turns this large gear here. I don't know if you've got enough light to see that. Then this entire structure, this and the bridge with it, comes this way. So if I was to remain standing here, that gear would eventually hit my knees. This is all static. So the whole thing rolls this way. Where you're stood, Steve, on the decking, that doesn't move. This obviously doesn't move. So this will swing round here, and it swings at a 90-degree angle. It goes 90 degrees basically, so the bridge is open like that.
So it is possible then to stand where I'm standing?
Yes, you could stand where you are. If
Yeah.
I stood here, I'd get that, you know,
Yeah.
I'd have to squeeze out the way.
Yeah.
But yes,
Yeah.
and these are lubricated every fortnight. The opposite weeks, we lubricate the inside. So there's a couple of little places here where you put it. It's a filthy job. You can see the grease is horrible black stuff. We have to keep that well lubricated as well.
Okay.
It's a mucky old job.
Yeah.
And then all the weight is on this bed.
Okay.
I mean, obviously there's weight on it now,
Yeah.
but once those ends are off,
Yeah.
everything is done from here. This
Yeah.
is the turning point.
Yeah.
So you got, you got 36 of these.
Yeah.
And they're all the original ones.
Unbelievable.
It's testament to the Victorian engineering, really, isn't it? You know?
Grossly over-engineered,
Yeah.
but will last
With
forever.
good reason, yeah.
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 Yeah, okay.
So that's basically how we operate. That then comes around, as I say, that comes around at 90 degrees. Then that stops at that point. I will just say, the bridge used to swing the other way.
Okay.
So if you were to go back to the early 50s, the bridge actually opened in the opposite direction. So it would swing that way, like that, instead of how it does now.
Okay.
Because you can see this gearing goes all the way around.
Okay.
At the moment it's set to go in that direction.
Brilliant. Thank you very much. So Robin has brought me down into this area. So Robin, what do we have here?
Right, so this area is immediately under the turret, control turret. What you're looking at there, Steve, is the bottom of the levers that we were looking at earlier in the top.
Oh yes, yes.
As you can see, they're just slaved into some
okay.
switch work there.
Yep.
So this is the original. This is the beating heart of the machine, if you like.
Right.
So this is all the original water hydraulic system. There are still things that operate down here. The large wheels there, you can see, they still turn because they still drive the quill shafts that turn the bridge. But there's no water hydraulics. It's driven by two electric hydraulic motors, which
Okay.
are in that cage over there.
Let's have a look at them.
So there you can see them there. So you can see the hydraulic pipes coming into the end there.
Yeah.
So they are a relatively modern addition. They were put there in the early 80s.
Right. Okay.
All the other items over here are the original hydraulic pumps and motors. Now on this one here, if you come across here, as these are heritage items, we've
Which
even
ones are
got a
we talking
system here, this motor here.
Yes. Yes.
We put the light on, and if I press this button up here, they're keyed in to operate purely from a visual point of view.
Oh wow! Look
As
at
to
that.
how they used to operate.
Yeah. Yeah.
So the pressure from those pistons would have come from the accumulator in the big green tower across the road.
Right. Oh right. Okay.
And that is what would provide the power then
Uh-huh.
to turn the big quill shafts there. As you can see, they go out the window or out through the structure
Yeah.
onto those enormous gears outside.
Wow.
And that is still how the bridge is slewed today.
Really? So
Just
it's all
using hydraulic motors now instead of the water system.
Okay. Okay.
So this is basically just redundant now.
Yeah. So
But
all those
obviously-
shafts and bearings outside are still operating.
Yes,
the
they're
bridge.
fully operational. Yeah,
And they've been here since
1897.
Wow.
Yeah.
Yeah.
With the
what
new electrification system, they will become pretty much redundant, but they will still turn. They'll be free to caster. We can't get rid of them. We don't want to get rid of them because they're part of the heritage of the bridge.
Yeah.
So they'll just be free to caster. The clutches will be disconnected and they'll just turn because the actual driving will be done from down the bottom.
Oh, that's fantastic. Yeah.
But as you can see, we need to do a fair bit of polishing up here from time to time. We get up here with the wad pole and the brasso.
Oh,
Look,
yeah,
we've got
yeah.
brasso down here.
Oh, wow,
So,
yeah,
we're quite busy up here, but it's
Yeah.
not much room to stand up, as you can
No,
see.
I see that, no.
We're about 5 foot of
Yeah.
head height, I think. So,
Yeah.
so
So in summary, really, although it's modernising gradually, that all this heritage stuff that we see here is still looked after,
Yeah.
and
Yeah.
is still, broadly speaking, operational.
It is.
Yeah.
And across the road in the hydraulic house, a similar setup is over there. And one of our operators lives over there. It's now a private residence, but he's got a large area where he's got all this sort of stuff in the bottom of the tower that he occasionally lets people in to have a look. And he looks after it beautifully. It's fantastic. So,
Oh wow.
yeah.
Yeah.
So if you ever get a chance to go in there,
Yeah.
it looks wonderful.
Yeah. Well, let's save that for another day. But this is fantastic. Thank you very much, Robin. So this is probably the highlight of the video, as we get to see all the practices that Robin described to us put into practice as we watch the bridge open, a boat go through, and then it closes again. So this is quite an interesting bit, really, where the boat is now passing through the 21-metre width that the ships have to go through. Obviously this thing is going to go through quite easily, but you can see how a 16 or 17 metre wide ship takes quite a bit of skill to manipulate through this quite narrow gap, and the tolerances are quite small. But obviously this boat passes through quite easily. So as the bridge returns to its closed position, we can see that it will return to all its blocks, as Robin so aptly described, and it will be reopened to traffic once again.
So having gone out for a little short spin, we're on our way back, and we're now about to cross over the bridge again back into Norfolk. We can see it coming up on our right here. I hope that you enjoyed this little look, an insight into what is a very prominent landmark here on the Norfolk-Lincolnshire border, and I hope that you found it all very interesting, and I hope you enjoyed Robin's comments and commentary and insight into the operation of the bridge and how it works. So I think that probably is about it for today. So I'd just like to thank Robin and Peter at the Sutton Bridge for their help and cooperation in the making of this video. Like I said earlier, I hope you found it interesting and informative, and I have to say I certainly enjoyed going around and having a look at it in detail and watching the thing open and close. It was fantastic, a fantastic experience, which I hope you enjoyed. So, without further ado, until next time, as we say here in Norfolk, do you keep on a troshin', boy?